I am Lishupi LM from Sigunelo Secondary School. So under cycle geometry, we are definitely going to look at the definitions of the following. Now, I would like to first start by defining the term Euclid. Now, Euclidean geometry is the study of plane, solid figures on the basis of axioms and theorems employed by the Greek mathematician Euclid. Now, when we now define the term a theorem can be defined as a rule, principle, or a statement that can be proved to be true. It is very important before we start with a topic to understand what does the term Euclidean mean, and also what does the term theorem, how can we define the term theorem. Now let us move on to our next slides. Now remember in grade 11, you did the basic cycle terminologies. So under the basic cycle terminologies, you had to define all these terminologies that we find onto our cycles, mainly an arc of a cycle. We can definitely say this part of a cycle, we name it an arc. And then now this portion that you see, we now call it a segment. And then a chord is a line with the endpoints on the circumference, which means any line that any line where now its endpoints are on the circumference, we can call that line a chord. So this is our chord. This is our chord. And then now this portion, we call it a segment. And then now when it comes to a radius, it is a line that it comes from the center of the cycle to any point on the circumference. Well, so whenever you are given a radius, it doesn't mean it will only be in one direction. No. As long as it comes from the center of the cycle to any point on the circumference, therefore, that is that straight line, that line, we call it a radius. Now, a diameter, it is a line passing through the center of the cycle. And also, diameter is double the length of the radius. And now, this portion of our cycle, this part of our cycle, we call it a sector. That slice of pizza, we normally call it a sector. And then now, a line that passes through 2 points on a cycle, like between the cycle, this line, we call it a what? We call that line a secant. And then lastly, but not the last, a tangent. A tangent, it is now defined as a line touching the cycle at only 1 point. So a line that touches the cycle only at 1 point, we call that line a tangent. So before we start with this Euclidean cycle geometry, you must understand the basic cycle terminologies. Thank you. So now moving on to our next slide. Yes. Moving on to our next slide, these are the theorems which you were taught last year. So according to these theorems, we normally group these theorems according to, we have the group 1, which is the center group, we have the no center group, we have the cyclic quads and the tangents group. But with me, I will not dwell into explaining these. However, I have created a toolbox which will definitely assist in how to apply these theorems. The toolbox that we'll be looking at, it will also be assisting us with now applying the theorems, these theorems. Now let us quickly move to our toolbox. Now, onto our toolbox. Now this is the basic geometry of lines which you were taught in grade 8 and 9. So now when we have parallel lines, whenever you are given parallel lines, just know that alternating angles are equal. So that simply means alternating angles. You see that this angle and that angle are alternating angles. And also, whenever we are given parallel lines, we know that corresponding angles are equal. And then corresponding angles, we normally say they form an F shape. So that simply means they lie between two parallel lines. Therefore, this angle and that angle are equal. And then lastly but not the least, whenever you are given parallel lines, co-interior angles are supplementary. That simply means when you add this angle and that angle, they should give you 180 degrees. So you only apply these when you are given parallel lines. How to prove that lines are parallel? Remember, this is maybe the two lines which you are supposed to prove. And then now, what is it that you must prove? You must prove that angle A, it is equals to angle B, which means A and B, if you check, they form alternating angles. And or you can also prove that angle A and angle D are equal, and then angle A and D, they form corresponding angles. And you must prove that they are equal, remember, because you are supposed to prove that these lines are parallel. And then also, to prove that lines are parallel, you must prove that angle B plus C, the sum of the two, they give you 108. So for us to prove that two lines are parallel, you are supposed to prove alternating angles equal, corresponding angles equal, and then you must also prove that co-interior angles are supplementary. Yes. Then again, we are still on our toolbox, remember. Now, if you are given on your statement that angle or a line bisects, so the minute you are given an angle or a line bisector, so if BD, you are given this line BD, that it bisects angle ABC, then what does that mean? It simply means angle B1 it is equal to angle B2. And then if you are given that CD bisects line AB, then that simply means AE, it is equals to EB. So remember, the statement can also give you this information to say angle ABC, line AB bisect angle ABC. Then you know, the minute they then mention bisect, you know that it simply means angle B1, it is definitely equal to angle B2. This is your toolbox, remember. And then under toolbox, you must also understand the triangle information. What does it mean? It simply means if now triangle ABC, it is an isosceles, right? Now you are given angle B being equal to angle C. So let's assume that the sides are not there. The sides are you are not supposed to know the sides. However, you know that angle B, it is equals to angle C. Then it simply means side AB will then be equal to side AC. And then if AB, it is equals to AC, then angle B is equals to angle C. So now that simply means triangle ABC, it is an isosceles triangle. But now let us go back to our reasoning. How are you supposed to reason? Remember, if you are about to say at side AB, it is equals to AC. But then you only have angles that are equal. You will definitely state that angle B is equals to angle C. This is given. So if angle A is equals to angle C, given, therefore AB is equals to AC. Reason, that will be sides opposite equal angles. Or alternatively, you are given AB equal to AC. So if AB is equals to AC, therefore angle B is equals to angle C, and then the reason for that will be angles opposite equal sides. So this is your triangle information. And then on the second one, we know that angle A plus angle B plus angle C2, the sum of interior angles of a triangle, they add up to 108. So that is the triangle information that you need to know. Therefore, also under triangle information, we know that the size of angle E2, it is equals to angle A plus B. Reason for that is an exterior angle of triangle. And then the third one under triangle information is that if you are given that AB is equals to AC, which is also equals to BC, then angle A will be equal to angle B, which is also equals to angle C. All of these three angles will definitely be equals to 60 degrees. And then if that's the case, that simply means triangle ABC, it is an equilateral triangle. So these are the toolbox that you must know, you must have in mind whenever you answer cycle geometry. Right. And then under, again, our toolbox, like I indicated, when you must prove two sides are equal. Now, if you must prove that two sides are equal, to prove that you must then check where are the sides located. So that simply means to prove that AC is equals to CD. That simply means you must prove that angle C1 or 2, either you prove angle C1 as 90 or you prove angle C2 as 90 degrees. And then to prove that AB is equals to AC, you must prove that AB is equals to AC. So for you to be able to prove that AB is equals to AC, you must prove that the angle B, it is equals to the angle C. And then, or another scenario, to prove that side AD, this is side AD, is equals to side BD. That simply means if you were to prove that this side is equals to that side, you can try and prove for congruency between triangle ACD and triangle BCD. The other scenario which I did not cater for is now it is now when you are having let's say I want you to prove that this chord it is equals to this chord. So let's say we have chord AB and then chord CD, and then this is F, this is E. So you are supposed to prove, your RTP, prove that AB, it is equals to CD. So to prove that AB is equals to CD, you must prove that angle E is equals to angle F. So which means for you to prove that this chord is equals to that chord, you must prove that angle E is equals to angle F. This is your toolbox that you are going to use to answer the questions. Yes. And then moving forward onto our next slide. Now, if you are given a center, the minute you are given a center, just remember that you must look out for what? You must look out for the angle which is now subtended by an arc at the center. And then, you know, if we have an angle subtended by an arc, remember an arc is this part of the center. So you must look out for the angle subtended by an arc at the center of the circle. We know that an angle subtended by the arc at the center of the circle, it is equals to 2 times the angle subtended by the same arc at the circumference, which is now our angle at center is equals to 2 times angle at circumference. Now this theorem, it comes with what? 4 different diagrams. This is the first diagram that you must look for, and then the second diagram that you must also look for, and then this is the third one, or you can also look out for this one. So any of these 4 diagrams you can look at, right? For you to be able to use what? To use angle at center is equals to 2 times angle at circum. And then moving forward, we are still on to our toolbox. If you are now given a diameter, now when you are given a diameter, you must then do what? If AOB is a diameter, then you know that angle C is 90. Reason will be angle in a semicircle. Now, angles in the same segment are given. Now you are given angles in the same segment. Remember, very important, NB. Angles formed at the circumference. These angles both must be formed where? At the circumference. So now, if you are now given angles at the same angles in the same segment, those both angles must be formed where? At the circumference. So if A, B, C, D are concyclic, which means these points are around the cycle, they lie on a cycle. If AB, AC, BD, and CD are chords of the cycle, then we know that angle A is equals to angle D, and then angle B is equals to angle C. Angles in the same segment. Yes, so we are still on to our toolbox. Now, the third one, another one on the toolbox is that if you are now given a cyclic quad, you know that a cyclic quad, all 4 vertices must lie on the circumference. Now, if ABC is a cyclic quad, then we know that angle A plus C is 180, and then angle B plus D is also 180. These are opposite angles of a cyclic quad. And also, if LMOP is cyclic, then angle M2, which is this one outside, angle M2 is equals to angle P. This is an exterior angle of a cyclic quad. And then if EFGH is cyclic, then angle E1, it will definitely be equal to angle H1, and then angle E2, it will definitely be equal to angle F2, and then H2 is equals to G2, G1 will definitely be equal to F1. These are angles in the same segment. So it is very important to master your toolbox. It will definitely be helpful when it comes to activities, you having a better understanding of cycle geometry. Now, how to prove that a quadrilateral is cyclic? Now, whenever you are supposed to prove that a quadrilateral is cyclic. So remember, ABC would be a cyclic quadrilateral if you could prove one of the following. The first condition, if you were to prove that angle A1 plus 2, which is the entire angle A, and then plus angle C2 plus 3, which is angle C, DCB, which is this angle C2 plus 3. If you could prove that these two are supplementary, which means the sum of these two are 180, then we know that quadrilateral, it is definitely cyclic. And then also, you can also prove B1 plus B2 is equals to D1 plus D2, the sum of the two, supplementary. So if you could prove that the angle B plus angle D, the two angles add up to 180, therefore we know that the quadrilateral, it is definitely cyclic. And then the second condition, we are now going to prove C1 equals to A1 plus A2. So if you could prove that angle C1 is equal to angle A, therefore we know that the quadrilateral is cyclic. And then the third condition, we are going to prove either angle A1, this angle, equals to angle B2, or you prove angle A2 being equal to angle D1, or you could prove B1 equals to C2, or D2 equals to C3. Right. Yeah. And then moving again into our toolbox. Now, if tangents are given, you will then look forward. Any line from the center to the tangent, you know that that line, it is perpendicular to the tangent. Hence, we have tangent perpendicular to radius. And then whenever you are given tangents that are from the same points, you know that tangents that are from the same points are equal in length. And then again, if you are given a tangent, you know that Tanchord theorem, where now we will be having an angle between a tangent and a chord, which is this angle, then being it equal to what the angle in the alternate segment. So Tanchord could either be acute case or it could either be an obtuse case. And then this is, I believe, our last slide on our toolbox. You must prove ABC is a tangent if the size of angle OBC is 90. So the minute angle OBC, this angle is 90, we know that ABC is a tangent. And also, for us to prove that DCE is a tangent, it is a tangent if angle C1 is equal to angle H. And ABC would be a tangent to the imaginary circle drawn through what? EBD if angle E is equal to angle B1. Now, these slides, they contain all your toolbox. What is it that you are expected to know before attempting to answer your what? To answer your cycle geometry. Now let us go to our activities. Now on to our activities. Like we know, we have about 5 or 4 theorems which you are expected to know how to prove. So now, with regard to these theorems, I will leave this question to your educators at your school to assist you with proving this theorem. So now, I will move on to our next activity. Now, with cycle geometry, you must then read the statement. The statement reads as follows. In the diagram below, O is the center of the cycle. Diameter LR subtends angle LKR at the circumference of the cycle and is another point on the circumference, and chords LN and KN are drawn. So angle L1 is equals to 58. Now, before you then attempt to answer the questions below, let us quickly remember our toolbox. Remember, on the statement, they have mentioned what? The diameter. Remember, I said if a diameter is given, the angle subtended by the diameter is what? Is 90. So you are told from the statement that LR is what? LR is a diameter. So if LR is a diameter, that simply means angle LKR, which means this angle is what? Is 90. Angle in a semicircle. And then from this, also remember you are now creating your smaller tools to understand the diagram. You study the statement together with the diagram before attempting to answer questions, so that you have a clear understanding of what is given to you, what is happening. And also, remember, I could see that chord LN and chord LR and KN and LN are drawn. So that simply means I now have what? Angles in the same segment. So angles in the same segment are what? That is where now you are looking at your what? Your angle L2, this angle, will definitely be equal to that, because now you are given angles in the same segment. Why are we saying they are angles in the same segment? Because both angles are where? They are subtended where? At the circumference. So hence we are using angles in the same segment. Now, the minute now you have studied your diagram, that is where now you go to your what? You go to your questions. Now, the first question, it says, calculate, given reasons, the size of angle LKR. So now remember, onto your toolbox, you have already mentioned that angle LKR is 90. So now here is just you applying. So angle LKR is 90 degrees. And then the reason for that, remember, because you are given a diameter, and we know that the angle subtended by a diameter at the circumference, it is 90. So the size of angle LKR is 90. This will be what? Angle in a semicircle. And then 9.2, you are now supposed to answer the size of angle R. Now, for us to calculate the size of angle R, you then notice what? You must then notice that triangle, we have triangle L, K, yes, R. So this is a triangle. So remember, according to our triangle information, we know that the sum of interior angles of a triangle, they add up to 180 degrees. So I know that the size of angle R, I will definitely have to what? To then add angle L1 plus angle K plus angle R. So the sum of the three angles, they must add up to what? 180 degrees. And then the reason for that, these are sum of interior. Please emphasize interior because it's important that you know that we are adding the interior angles of the sum of interior. 58. So that will be 58 plus 90, because now we know angle LKR is angle K, K1 plus 2. So the size of angle K is 90 degrees. So 58 plus 90 plus R is equals to 180. Therefore, angle R is equals to what? Remember, that is where now you will be using your calculator then to calculate the size of angle R, which is 32 degrees. Now you have to know that the size of angle R is 32. And then again, 9.3, you are supposed to calculate the size of, this is 32 degrees. And then 9.23, you are supposed to calculate the size of n. Now, when you look at my diagram, you will then see that not only L2 is equals to K2, but angle R is equals to angle N. These are also angles in the same segment. So therefore, the size of angle N will definitely be equal to 32 degrees. These are your angles in the same seg, which means when you check these two angles, they are subtended by the chord LK. So the two angles, they are subtended by the chord LK, or you can say the two angles are subtended by a chord LK. So the same arc, so this arc also subtend these two angles. Hence we say the angle N is 32 angles in the same segment. So if you do have your toolbox ready, you will never get this chapter wrong. You will forever be getting it correct. Let us move on to our next question. Right. So this is also a numerical question. So whenever you are given the sizes of the angle, when you know that this angle is 68 degrees, you know that these type of angles, this type of questions are your what? These are your numerical questions. Yes. Now, in the diagram, PQRS is a cyclic quadrilateral. Remember, what did I say? The minute the statement mentions cyclic quadrilateral, remember that opposite angles of a cyclic quadrilateral are what? They are supplementary. So now, and also you read the statement, PS and QR are produced and they meet at T. So when something is produced, it simply means it is extended. So if you check the line PS, it is extended to where? To T. And then the line QR is extended to what? To T as well. So now they are extended such that they meet where? They meet at point T. So you must also conceptualize the language of our and then PR bisect. Remember our toolbox. If we say a what? A line bisect from our toolbox, PR bisects QPS. Also, PSR is equals to 92 and QPS is equals to 68. Now, if you remember when let me go back onto our toolbox when I started, I did mention that the minute you are given a line bisector, if BD bisects an angle, then what does it mean? It simply means the size of angle B1 is equals to angle B2. So in this case as well, it will definitely mean the same thing because they are saying this line PR bisect. So this line, it bisect what? It bisect this angle. What does it mean? According to our toolbox, it means that the size of angle P1, I will definitely make a star. Angle P1 will equal to angle what? Angle P2. So what you are then now doing, you are now conceptualizing, you are now doing what? Making use of your toolbox. Hence, it is important to understand and apply your toolbox before attempting to answer the questions. You read your statement. From the statement, you try by all means to make sense out of the statement, remembering your toolbox, what you were taught about your toolbox. And then what I know also is that the size of angle QPS. I know normally at school we will say angle P. So the size of angle P, you are given it as what? The size of angle P is 68. Then remember again from what? From the statement, you are given that PQRS. PQRS, it is a cyclic quadrilateral. You go back to whatever you do, you must also ensure that you must also make sure that you now do what? You go back to your toolbox. According to our toolbox, we indicated if A, B, C, D is your cyclic, is cyclic, then which angles are supplementary? This angle plus that angle. When you add the two, they must do what? When you add the two angles, they are supplementary. So we know the supplementary angles, they add up to 180. So every time when you answer these type of questions, remember to always go back onto your toolbox. So now, because you are told that P this is your cyclic quad. So if you are told that this is your cyclic quad, you know that the size of angle P plus angle R2 plus 1. So which means angle P plus R2 plus 1. And then you can also make your smaller notes to say angle P plus angle R1 plus angle R2. The two, when I add, they must give me 180. And then the reason for that, these are my opposite angles of a cyclic quadrilateral. And also the size of angle PSR plus angle Q. This must also give me 180 degrees because it's cycle geometry. Remember, whatever you do, you must provide a reason. Why am I doing that? So therefore, the size of angle PSR, which is 98, when you add it plus the size of angle Q, the two must add up to 180. Remember, these are your what? These are your opposite angles of a cyclic quad. So it doesn't matter whether the diagram given is complex or not. If you use this technique, you will never go wrong. And also, on our statement, I believe you were told that PQRS, it is cyclic. If PQRS, if I remember well, from our toolbox, if it is cyclic, then we know that the exterior, this line OM, which is extended, the exterior of this angle M2 will definitely be equal to the interior opposite angle. So that is how you now do what? Apply your toolbox. So now all I know is that because now that QR is produced, the minute they mention produced, I know there's a straight line. So if it's produced, I know that the size of angle R2, R3 I meant to say, will definitely be equal to angle P. Reason for that, it is an exterior angle of a cyclic quad. Similarly also, the size of angle S1 will definitely be equal to what? To angle Q. These are what? These are your exterior angles of a cyclic quad. So I believe by now you have exhausted your toolbox, even though you did not mention your triangles and what, but I know you still have triangles. So you must ensure that when you are given a diagram, exhaust all your tools. You must bring all your tools and then apply what you know based on the information and the statement given. Now, then we can answer the questions, of course. Calculate the size of the following angles. Now, you are supposed to calculate the size of angle RPT. Now, the size of angle RPT, remember, you follow the sequence. Angle R, right? The size of angle RP and the size of angle RPT, that's T. So the size of this angle, remember, you were told that this line is a bisector. So the minute this line is a bisector, it does what? It halves this entire angle. So that simply means the size of angle RPT will be what? The size of angle RPT will be equal to what? It will definitely be equal to 34 degrees. So that one, it does not require a reason. But you know, on your statement, you were given that PR bisect, which means that line, it is a what? It is an angle bisector. Yes. And then 10.2, you must then calculate the size. So numerical question, they will forever say the size if they want you to calculate the angles. So you must calculate the size of angle TQS. Now, if you were to now calculate the size of angle TQS, angle TQ, right? Angle T, I believe QS. We are now looking at which angle? Angle TQS. This is the size of, we are now looking into this. Now, because you know SR, QR, QP, and PS are your what? These are your chords. So therefore, I can see that this angle, which is angle P2, it will definitely be equal to angle Q2. Q2, these are what? Are my angles in the same segment. So the size of angle TQS, it is equals to 34 degrees. And then reason will be angles in the same seg. Even though I did not include this on my toolbox, but it is also applicable. And then the next question, you are supposed to also calculate the size of angle PQS. Now, to calculate the size of angle PQS, what is it that you must do? It simply means we want the size of angle QY. It is the size of angle PQS. We want the size of angle Q1. Now, from your toolbox, you know that angle Q, it definitely include angle Q1 plus 2. And what you know is that angle PSR plus angle Q is 180. So that is what you are going to use to answer this question. Remember, from your toolbox, you have now seen that angle PSR plus angle Q, this is 180. These are my opposite angles of a cyclic quad. So therefore, the size of angle PSR is 92. So 92 plus Q is equals to 180 degrees. Therefore, angle Q is equals to angle Q is equals to what? Is equals to 88. Now that I know that angle Q is 180, then I know that the entire angle Q is 88. And then the size of angle Q2, I know is 32. This angle is 30. This angle is 32. This angle is 32. 34 degrees. So that simply means what? To calculate the size of Q1, which is angle PQS, I will definitely say 88 minus 34. So therefore, 88 minus 34 will definitely give me 54 degrees. And then the last question, calculate the following angles. You must then calculate the size of the following angles, angle T. So that is angle T. So for us to get to angle T, we will then have to look what? We will definitely have to look at our diagram again. So we will definitely have to look at our diagram. Now when you look at our diagram, you notice something. P, right? P, Q, T. And yes, when you notice that PQT, yes, PQT is a triangle. That is when now you will be using what? Using your triangle information, which I believe is some of the what? It's property of triangle. You know that the size of angle P plus angle Q plus this angle, they must give you 108 because PQT, it is a triangle. That simply means you will say angle P plus angle Q plus angle T is equals to 180. These are some of interior angles of triangle. So therefore, angle P at 68 plus 88 plus T is equals to 180 degrees. Therefore, angle T is equals to 180. That will definitely be 180 minus 88 minus 68. So the size of angle T will be 24 degrees. That is why I still maintain that please do understand how to make use of your toolbox, because even triangle information is part of your toolbox. All right, moving on to the next slide. Remember, I tried to look for diagrams that are not that complicated. Now, on our next slide, you are given this diagram, and then the statement, it reads as follows. In the diagram, M is the center. In the diagram, M is the center of the cycle. And then we have A, B, C, K, and T. They lie on the cycle. And then AT is produced. Remember, the minute they mention something is produced, you just know that if they say AT is produced, just know that something produced means it is extended. Okay, so AT is produced and CK is produced meet in N. So now this is the point of intersection between AT and CN. And then also you are given from the statement that NA, so NA, this is your NA, this side is equals to NC. So this is what you are given on the statement. And then the size of angle B is 38. Now, before you move to questions, what is it that you must do? Remember your toolbox. Read what is given. You must read the statement. Out of the statement, you look onto a diagram and make sure that you then use your toolbox. You make use of your toolbox. Now, from my statement, I can see that now I'm given the center. So that simply means when you are given the center, I know that if I'm given the center, I will be having this. So I know that this angle is twice that one, which is now angle subtended by an arc at the center. This is the angle at the center is equals to 2 times the angle subtended by the same arc where at the circumference. And also, using my toolbox, I can also say the same angle at the center is also a angle at the circumference. So there are so many ways. And then again, using my toolbox, I can also say, now I also have an arc subtending. So the angle subtended by the same arc, which are these angles? Angle C and then angle A. These are the angles in the same segment, which means this angle and that angle are equal. And then yes, and then this one will definitely be equal to that one. Okay. So this is how you do it. This is how you check your toolbox. And then also, if I may mention, you are given that CN, NC, and NA are equal. What does it mean? It simply means that triangle CNA, it is a what? It is an isosceles triangle. That is why whenever you answer these type of questions, you must have your tools ready. So you must gather all the information. Now, even though it was not mentioned on the statement, I can also see that I have the following slightly quadrilateral. I have C, K, C, A. It's a slightly quadrilateral. Why? Because all vertices are on the circumference. And also, I have another slightly quadrilateral, B, K, N, A. It is also a slightly quadrilateral. All 4 vertices are where? Are at the circumference. So as you are busy finding out what is happening with your diagram, you are also making notes. Then that is when now you will have your tools ready. Whatever you have found out, you must ensure that you write it down to indicate that the size of angle KMA. Remember, this is just a toolbox. KMA is equals to what? The size of angle KMA, you must double it. So 38 times 2, it is 76. And then remember I said this is angle at center is twice angle at the circumference. And also the size of angle C, it is 38. And then reason for that, key angles in the same segment with angle B. They are angles subtended by this angles subtended by an arc at the circumference. So these are the angles in the same segment. And also from my toolbox, I could say that angle C, it is definitely equal to angle CAN. Remember, angle C is equals to angle CAN. And then the reason for that, they are what? Angles opposite equal sides. Why? Because on your statement, you were told that NC and NA are equal. So the minute you are given NC and NA being equal, you know that the angles that are opposite to those sides are equal. So triangle CAN, it is your isosceles triangle. Okay. And then also on my toolbox, I indicated that BATK, it is cyclic. So therefore, the size of angle T1 plus angle B, these two must give me 180 degrees. And then the reason for that, these are what? Opposite angles of what? Of a cyclic quadrilateral. So opposite angles of a cyclic quad. And yes, I believe. And also from this, you were told that this line is a straight line, so it's extended. So I know that the size of angle K2 will be equal to angle B, an exterior angle of a cyclic quad. So the size of angle T2 is equals to 38. This is my exterior angle of a cyclic quad. So it is important that before attempting to answer questions, just ensure that you do make your own toolbox, create your own toolbox somewhere of what you see, what you can see from the diagram before answering any questions. Right. Now we can definitely move to questions. Now when we move to questions, the first question is that you are supposed to calculate the following. You must calculate the size of the following angles. You must calculate the size of angle KMA, and then calculate the size of angle K2, the size of angle C, and then the size of angle K4. Now when you check your toolbox, KMA is there. Angle T2 is also there, KTAT, and also angle C is also there. So that simply means by you creating your toolbox already, these questions, you have already answered them. So that is why it is important that you read your statement and you check your diagram. From the statement and the diagram, you use your toolbox to answer that diagram without looking at the questions. Yes. So now you agree with me. The size of angle KMA, we said is 76. And then the reason for that, it will be angle at center is equals to 2 times angle at circum. And then the size of angle T2, angle T2 will be 38. This is your what? 38. This will be your exterior angle of a cyclic quad. And then the size of angle C is 38. Remember why angle C is 38? We also indicated that the size of angle C plus angle B, it is equal, they are angles in the same segment. So which segment? You could see that this chord CK and KN. And then, yeah, yes. So therefore, the size of angle C is 38. These are your angles in the same which is the same segment. Now, to calculate the size of angle K4, to calculate the size of angle K4, remember with regard to as far as cycle geometry is concerned, for you to calculate the size of K4, there are so many ways to calculate the size of K4. However, what you can also use, you can also use cyclic quadrilateral KCAT. So you can use the cyclic quadrilateral KCAT. So when you use the cyclic quad KCAT, it simply means angle K4. It is an exterior angle. And this exterior angle, it is equals to what? It is equals to an interior opposite angle. So that simply means, I believe somewhere I mentioned the size of angle CAN, which is equals to angle C. So now you can also now write it in context, write it down. So we said angle C, it is equals to angle CAN. They are both equal to 38 degrees. The reason for that, remember, these are angles opposite equal sides. So now that we know that angle C is equal to angle CAN, both of these angles are equal to what? Are equal to 38 degrees. They are angles opposite equal sides. Therefore, the size of angle K4, it is equals to 38 degrees. And then the reason for that, this is your what? Exterior angle of a cyclic quad. So with regard to this one, we have used which cyclic quad? We use the cyclic quadrilateral CATK. Yes. So now you have answered the question, the size of angle K2. But I believe there are so many ways to do that one. And then now, when we move to 10.2.2, remember now, you are supposed to prove or show that NK is equals to what? NT. Now, you are supposed to show that NK, this is equals to what? Is equals to, NK is equals to NT. This is NK, this is NT. So this is what you are supposed to do. What? This is what you are supposed to prove. So now we'll erase everything on my diagram so that now it's clear. So what we are supposed to prove is that this line is equals to that line. So if you remember on our toolbox, we did mention if you are supposed to prove that Kn is equals to Nt, you can also prove by what? Let us go back to our toolbox so that we remind ourselves what I was said, and then remember, for us to prove that this side is equals to that side, I must prove that angle B is equals to angle C. So that means I must prove that triangle ABC, it is a what? An isosceles, by proving that the size of angle B is equals to the size of angle C. So that is why it is important whenever whenever you attempt to answer these questions, you must always refer back on your tools. Yes. So as I was saying, you are supposed to prove that this side is equals to that side. So for us to prove that this side is equals to that, we must prove that angle T2, we must prove that angle T2 is equals to angle T4. And already we have done what? We have calculated the size of angle T2. The size of angle T2 is what? Is 38 degrees. This is the size of angle T2. And also the size of angle K4 is what? Is also 38. So if the two angles are now equal, I know that the size of angle T2 elegantly the size of angle K4. This was then what? It was proved, already proved from the questions above. So if that was proved, I can definitely conclude to say, therefore, NK, it is equals to NT. And then the reason for that, remember our isosceles. If in our isosceles, let us go back to the toolbox so that we remind ourselves. Remember our isosceles. I did mention if you have angle B equal to angle C, then we can conclude to say AB is equals to AC. And then the reason for that would be what? These are what? Sides opposite equal angles. So you will be using the same reason to answer that question. That simply means the reason for that will be what? These are the sides that are opposite to what? To equal angles. Sorry. So these are the sides opposite to what? To equal angles. So hence I emphasize, please, ladies and gentlemen, know your toolbox. Let us ensure that when we answer cycle geometry, irrespective of whether we are answering cycle geometry using, this is numerical questions, and also in riders, the two are still the same. You use the same approach to answer cycle geometry. Right. Let us now move to question 10.2.3. Right. You are now requested. You are now required to prove. You are supposed to prove that AMKN is a cyclic quadrilateral. So when I go back to my diagram, I am going to check where does this AMKN lie. So remember, you are supposed to prove that this is AMKN. So you are supposed to prove that this is your cyclic quadrilateral. So according to our toolbox, how are we supposed to prove that a quadrilateral is cyclic? Remember, this is very important. How do we prove? To prove that a quadrilateral is cyclic, you must either prove that angle A plus C1, C2, and 3 is 180, angle D plus angle B, when you add angle B plus D is 180, or you can prove the size of angle A is equals to the size of angle C1, or you can prove this angle being equal to that angle. So that is how you are supposed to prove that a quadrilateral, we have a cyclic quad. So now, ladies and gentlemen, remember, you are supposed to prove that AMKN, it is cyclic. So for us to prove that AMKN, it is cyclic, how are you going to prove it? Remember, we have the size of angle M, KMA, I apologize. The size of angle KMA, it is 76. So what we can then do, we can also calculate the size of angle N. How do we calculate the size of angle N? We use our triangle information. Remember our triangle information, it states that KT, N, triangle, the interior angles of these triangle, they add up to what? They must add up to 180 degrees. So that simply means angle K4 plus angle T2 plus angle N. This is 180 degrees. And then the reason for that is sum of angles in triangle. Okay. And then K4, the size of K4 is 38, plus the size of angle T2. Size of angle T2 is what? Is 38 as well. So plus N is equals to 180. Therefore, N is equals to 180 minus 76. So the size of angle N is equals to 104 degrees. So now, we know the size of angle N. So the size of angle N is what? The size of angle N is 104. And then what you then do, you will be then adding angle K, M, A plus angle N and see if the sum of the two, does it give you 180 or not? So KMA we said it's 76, and then plus the size of angle N, which is 104. 76 plus 104 is equals to what? Is equals to 180 degrees. So now that I have proved that the opposite angles are supplementary, what does it mean? It simply means therefore AMKN, therefore AMKN is a cyclic quad. And then the reason for that, you will definitely use converse of opposite angles of a cyclic quad by converse. So whenever you are supposed to prove a theorem, you then use what? The converse, because there is no circle. You are now using an imaginary circle to prove that. So by converse of opposite angles of a cyclic quad. This is how you are supposed to answer this question. Now let us move on to our next question. So whenever you answer Euclidean geometry, cycle geometry, please ensure that you understand your toolbox and how to apply your toolbox. So now, reading on to my statement. In the diagram you are given, you read the statement. Pn is a diameter of the cycle with the center O. RT is a tangent to the cycle at R, okay? And then RT is produced and Pn is produced mid at M. OT is perpendicular to NR, NT and OR are drawn. So it is important you must read and read and read the statement and make sense out of the statement. So from the statement, I believe they have mentioned the following: a diameter. They also mentioned the center. They also mentioned the tangent. And they also mentioned that we have a line from the center, which is OT, being perpendicular to what? To NR. And then you are also told that NT and OR, these are drawn. Okay. Now the first question, before you move to questions, remember your toolbox, very important. I know sometimes it's tempting, you just not want to take a snap on the questions. No, please, I will advise against it. Check your diagram, read the statement, and remember your tools. They mention diameter. So the minute they mention diameter, you must always know that according to my toolbox, the angle subtended by the diameter, where at the circumference is 90. So that means if Pn is my diameter, therefore angle R1 plus angle R2 is 90. That is my angle being subtended by this diameter. So my diameter is Pn. So you are told that Pn is the diameter. So the angle subtended by the diameter, this is the angle subtended by the diameter, which is what? Angle R2 and R1. So that simply means this is your toolbox now. I know that the size of angle R1 plus angle R2, they're supposed to give me 90. This is the angle subtended by the what? By the diameter. And then also, from the statement, you are given a what? A tangent. So you are told again from the statement that, RT, this is your what? This is your tangent. So this is the first question that we are now coming across, tangents. So remember, according to our toolbox, if now tangents are given, if you are now given tangents, remember we have an acute case of what? F chord. If we have an angle between a tangent and a chord, which is this angle, it will definitely be equal to what? The angle in the alternate segment. So that is the chord theorem. And then, yes. So now, in this case, you are given what? You are given the size of angle R3, not the size. You are given the tangent TR. So the tangent RT, remember, the angle between the tangent and a chord, which angle is that? You must then identify that if this is my tangent, this is my chord. Now, which angle is between the tangent and a chord? Angle what? R3. So therefore, angle R3, it is the angle between the tangent and a chord. Will definitely be what? An acute case chord, because this angle R3 will be an acute angle. So now the angle between a tangent RT and a chord RN is angle R3. So the angle between the tangent and a chord is equal to the angle in the alternate segment. Which angle is that one? That will be angle P. So which simply means angle R3 it will definitely be equal to angle P, and the reason for that will be then using the chord theorem to answer that. So yes, and also when I also continue reading the statement, yes, from the statement we have now created some tool there using our toolbox. Diameter, we know that this angle is 90, and then also we know that this angle is equals to that angle. That is what you can now use based on this diagram and the statement. And also from the statement, you were given that OT is perpendicular. So the minute we give you a line from the center that is perpendicular to a chord, we know that a line that comes from the center, if it is perpendicular to the chord, therefore that line does what? It bisects the chord. So that simply means if OT is perpendicular to RN, therefore RS will definitely be equal to SN. Line from the pair center to the midpoint of a chord. So that is your toolbox as far as this case is concerned. Now let us look at the first question. You are supposed to prove that TO is parallel to RP. Now, remember when I first started your toolbox, for us to prove that two lines are parallel, what is it that you must prove? So you can't just prove parallel lines without knowing what is it that you must prove. So remember when I first started, I explained, remember, how to prove that lines are parallel. So for us to prove that the two lines are parallel, you have the following to prove. You can either prove that angle A and B are equal. Now when you look at angle A and B are alternating, or you can prove that angle A and D are equal. When you prove that angle A and D are equal, it means you are proving corresponding angles. Now these two are what? They are alternating angles. So you must prove that alternating angles are what? Are equal. Or you must prove that what? Corresponding angles are what? Are equal. That's how you prove that lines are parallel. Or you must prove that angle B plus C, the sum of the two angles, when you add the two angles, you get a supplementary. So they are supplementary, which means you prove that co-interior angles are supplementary. So that simply means you must prove. This is what you do when you prove that the lines are parallel. Now, when you look into our diagram, we are supposed to prove which lines are parallel. Let me just erase so that we have a clear diagram. You are done with your tools. So let me just erase. Now, after erasing, Okay, which lines must we prove that are parallel? We must prove that TO, this line, is parallel to that line. So for us to prove that this line is parallel to this line, remember, what is it that we must prove? We must prove that at least angle OT is equal to angle R1. That's if you find the sizes of the two, or using either in terms of what. And also, you can prove that which angle? You can prove this angle here is equals to this angle. This angle, the two, because we are proving that OT is parallel to PN. You can also prove that the size of this angle plus this angle, if you check, they form that C shape. Yeah, they call interior angles. So you can prove that when you add this angle plus this angle, you get what? You must prove that they are supplementary. But already on your toolbox, you have mentioned that angle R1 plus angle R2 is 90. Do you still remember? Yes. So we did say angle R1 plus angle R2 is 90. And then the reason for that, R1 plus R2 is equals to 90. And then remember, the reason was it was an angle subtended by the diameter. So which means it is angle in a semicircle. So we know that the angle subtended by the diameter at the circumference is 90. So that simply means angle R1 plus R2 is 90. Sharp. And then remember, you were told from the statement that OT is perpendicular to Rn. Remember, when a line is perpendicular, we know that it creates an angle of 90 degrees. So that simply means the size of angle OSR is 90. This was given to you. So therefore, angle what? Angle R1 plus angle R2 plus angle OSR. This is what? 90 plus 90, which is 180. So that simply means angle R1 plus R2 is 90, and then that angle is 90. So 90 plus 90 is 180. Therefore, if that's the case, TO will definitely be parallel to RP. And then what will be the reason for that? The reason for that will definitely be co-interior angles are supplementary. They are supplementary. Supplementary. Yes. Then we move to the next one, 11.2.2. It is further given that angle TRN is X. So now it is further given that, so now you know that, yes, now that I have proved the lines are parallel, you can leave those marks. It definitely means those two lines are parallel. You have proved also they are parallel. So now you are further given that angle TRN, angle TRN, which angle is that? Angle R3. So it is further given that angle TRN is X. Okay? Now you need to name two angles other than each. Two angles, other angles each equal to 90. So we need you to name any other two angles that will be equal to 90 to X also. So remember, from your toolbox, you have mentioned that angle R2 is equals to angle P. Remember? Why? Because you have now established that RT is a chord, is a tangent. So if RT is a tangent, the angle between a tangent and a chord, which is R3, it is equal to the angle in the alternate segment, which is angle P. So which means to answer that one, you will definitely know that angle P will definitely be equal to what? To X. And then the reason for that will be Tanchard theorem. Then remember you must name 2. And then the second angle that you can also use. Remember your toolbox, you only did what? You only used the diameter and the tangent. Yes. Now, remember, we go back to the parts of the cycle. According to the parts of the cycle, when I started, I also mentioned that we have a radius, and a radius throughout the cycle is equal. So one thing I know is that ON, OP, and OR, when you check ON, OP, OR, these are your radius. So normally in plural we call them, they are radi. So that simply means we are definitely going to use which triangle? Triangle PO, triangle POR. Because we know the size of angle P is X. So what we will definitely do, we will have to use triangle POR. Then we know in triangle POR, OP, it is equals to OR. Remember, these are your what? Kidi radi. So if these are your radi, therefore, it simply means angle R1 will definitely be equal to what? Will definitely be equal to angle P. And then the reason for that will be what? These are the angles, because the sides are now equal. These are the angles opposite equal sides. And then these sides, we mentioned them. They are what? The two sides are right. Yes. So which means the side, and also angle R1 will definitely be equal to what? To X. So these are the two angles that are also be equal to what? To X. Thank you. And then 11.2.3. Prove that NTRO is a cyclic quad. So remember, when you prove that a line, it is a cyclic quad. When you prove that a line, it is a, when you prove a cyclic quad, right, yes. Now, if you are to prove that NTRO is a cyclic quad, you must follow the sequence. It is N, it's T, sorry, it's N, it's T, it's R, it's O. So remember, you must prove that there's a cyclic quad. Now, to prove that NTRO, it is a cyclic quad. Remember, to prove that we have a cyclic quad, to prove that a quadrilateral is cyclic, there are so many ways to prove. You could either, using your toolbox, you could either prove that O3 plus O2 plus T2 plus T1, that some of the two are supplementary. Or you could prove that angle N3 is equals to angle R2 plus 3. Or you can prove that maybe angle O3, it is equals to angle R3. So which means, or you can prove that N2 is equals to O2, or you could prove that angle R2 is equals to angle T2. So there are so many ways that you could prove that you could use to prove that NTRO is a cyclic quad. Okay, now from what I know is that you know that this is parallel to this, because this was already proved. You have proved that this line is parallel to that line. So if this line is parallel to that one, that simply means you will definitely use your parallel lines. You know, when you have your parallel lines, alternating angles are equal, corresponding angles are equal, and also co-interior angles are supplementary. So that simply means I will definitely check for that alternating angle. So I know that if this line is equal to that line, it simply means I have my Z shape. That means this angle will definitely be equal to that angle. So that means angle R1, it is equals to angle O2. They are both equal to X. These are alternating angles. And then after mentioning alternating angles, you must include those parallel lines. That TO is parallel to RP. Right. Now that you know the size of, not the size, you know that in terms of X, angle O2 is X, and then angle R2 is also X. Okay. We also know that this angle is X, sharp. And then when I look into my diagram, I can definitely see that in triangle POR, this triangle, remember, we mentioned that this side is equal to that side. It is an isosceles triangle. However, we also mentioned that this is a straight line, right? So that simply means using our triangle information, we know that the size, not the size, yes, angle O2 plus angle O3, when you add the two, this is an exterior, which simply means when I definitely go back to my toolbox, you will remember that I did mention under triangle information that if we have an exterior angle of a triangle, we will use that the size of angle A plus angle B, when you add the two, they must give you what? This angle, which is an exterior angle of triangle. So that is why whenever you answer cycle geometry, you must always remember your what? You must always remember your toolbox. That will be of much help to you. Yes, so as I was saying, therefore, you know that this is an exterior angle of a triangle. So O2 plus 3, it will definitely be equal to angle P plus angle R1. And then the reason for that, it is an exterior angle of triangle. So therefore, angle O2 plus 3 is equals to angle P is X plus angle R1 is X. So therefore, the angle O2 plus 3, it will definitely be equal to 2x. So therefore, this is 2x. And then I know that O2 is x as well. So that simply means O3 will also be what? I know that since O2 is x and O3 will be what? Will also be x. So that means this is also x. So therefore, O2 will definitely be equal to what? To O3. They are both equal to what? To x. Because remember, we have also indicated that O2 is what? It was x. So now that we know that the angle O2 is x and also angle A3 is x, that simply means, remember, we are still proving that NTRO, it is cyclic. So therefore, that means, remember, for us to prove it is cyclic, we were supposed to prove that this angle is equals to that angle. So therefore, angle R3, it is equals to angle O3. Yes. So now that R3 is equals to O3, therefore, NTRO is a cyclic quad. And then the reason for that, it will be converse of angles in the same segment. So the reason will be by converse of angles in the same sec. So this is how you prove that a quadrilateral is what? It is cyclic. We have a cyclic quadrilateral when we have an imaginary circle. Now let us answer question 11.2.4. And then to answer question 11.2.4, you have to calculate the size of angle M in terms of X. So because they mention angle M in terms of X, it doesn't mean it will only be maybe 2x, 10x. No, it will definitely either be maybe 180 minus x, but x will be there. Hence, we are saying in terms of what? In terms of x. So therefore, remember, now that we have now do what? You must check where M is. So let me first start by erasing my diagram so that we now look at angle M in a clean diagram. Yes. Now you are supposed to do what? You are supposed to calculate the size of angle M in terms of X. So as calculating the size of angle M in terms of X, if you check, we have P M R. So PMR, it is indeed a triangle, right? PMR, it is indeed a triangle. And then you know that more R1, R2 is 90, remember? And then this one is X, and that one is also X. So then we are going to use sum of interior angles of a what? Of a triangle, which is one of your toolbox, which is there on your toolbox. So therefore, angle P plus angle R plus angle M. This is equals to what? 180 degrees. So the size of angle P is X plus angle R. Remember angle R, we have R1, R2, which is 90, plus R3, which is X. And then that will be plus M is equals to 180. So the reason, whenever you write in cycle geometry, you must provide a reason. So the reason for that, it will be sum of interior angles of a triangle. So therefore, x, it will be 2x plus 90 plus M is equals to 180. Therefore, angle M is equals to 180 minus 90 minus 2x. So the size of angle M is equals to 90 minus 2x. Hence, now the question was calculate the size of angle M in terms of what? In terms of x. So this is angle M in terms of x. Right. And then we will then answer our last question, question 11.2.5. Now in question 11.2.5, you are supposed to show that NT is a tangent to the cycle at N. Now remember, to show that a line is a tangent to the circle, according to our toolbox, we might have an imaginary circle. So would be a tangent to the imaginary circle. For you to show that a line is a tangent to an imaginary circle drawn, you must definitely prove that the size of angle B1 is equals to what? To BE. So with regard to that one, for us to prove that a line is a tangent to the cycle at N, which cycle? To this cycle. for us to prove that this line N, yes, this line NT, it is a tangent. Let me erase. Okay. Yes. So for me to prove that the line NT, this is the line, it is a tangent to the circle. Which angles I must prove that are what? I must definitely prove that angle N2 is equals to what? Remember this angle? This is the tangent, and then this will be the angle. This is the tangent, and then this is a chord. So this is the angle between the tangent and a chord. So the angle between the tangent and a chord in this case is angle N2. So I will have to prove that angle A2, N2 is equals to what? Angle N2 is equals to angle what? Angle P. So if I could prove that angle N2 is equals to angle P, I will definitely know that NT, it is a tangent to the circle. So now, remember, already, previously, you have proved that this line is parallel to this line. You have also proved that ONT, yes, this NTRO, it is cyclic. So by now you know that I do have a cycle there. So now, because remember, you know this angle O2 plus angle O3, this is 2x. We also proved it. And then O2 is x. And then O3, it is also x. Also proved. Now, what we know is that if O NTRO, it is a cyclic quad. It simply means we do have an imaginary circle there. Ooh, we do have an imaginary circle. Yes, we do have an imaginary circle. We do have an imaginary circle here, which is not drawn. So we know at the back of our minds, yes, we do have an imaginary circle. So if we do have an imaginary circle, we know that the size of angle O2 will be equals to angle it will be equal to an angle N3, N2, I meant to say. So if this is x, also N2 is x. So they are both equal to x. Reason for that, these are the angles in the same segment. So one may ask, Melishupi, why are we using angles in the same circle where else we do not have a second? For the mere fact that we have proven that NTRO is cyclic, it simply means we do have a cycle there, even though the cycle, it is imaginary. Yes. So now, now that you have O2 being equal to N2, both of them being equal to x. These are the angles in the same segment. So now I know already angle P is equals to x. This was proved already, proven or proved. Remember, already we have proven that angle P is x. So now that angle N2, therefore angle L2 is equals to angle P. Why? Because both of them are x. It definitely means what? It definitely means, therefore, NT is a tangent. You make a conclusion. And then your conclusion must definitely be followed by a what? It must definitely be followed by a reason. NT is a tangent. Why? I have proved it by converse of tongue chord theorem. So now you have proved that the line the line NT is a tangent to the cycle at N. Ghana, why is it a cycle at the tangent at N? Because I will just erase this for convenience sake so that you could see it. If this line is a tangent to the cycle at N, therefore, if this line is a tangent to the cycle at N, it definitely means what? It definitely means this angle is equals to that angle. Hence, we are saying NT is a tangent. Why? Because of converse of Tancourt theorem. So, ladies and gentlemen, as far as Euclidean cycle geometry is concerned, please gather your tools ready. Be ready to gather your tools. Ensure that at the end of don't rush into now doing what? Don't rush into trying to answer questions. No, you use your toolbox. Your toolbox, it will open all doors to answer these type of questions. So what you do, you must ensure that you read the statement. After you read the statement, from the statement, you take whatever information read from the statement to where? To the diagram. And then you create your smaller toolbox that you are going to use to do what? To assist you in answering the what? The questions. So please let us try to be very careful. So I know most of us, when it comes to such questions of proof, such questions of proof, I know we find it very difficult for us to prove. But if you have your toolbox, everything is possible. It is even easy for you to answer these type of questions. So ensure that you do understand how to use your toolbox. Yes, it is well and good to know how to answer. How can I put it? To know how to know your theorems. It is well and good to know that the center group, we do have line from the center. The line from the center perpendicular to the chord. If the line from the center is perpendicular to the chord, therefore the line bisect. But now you must understand it deeper, have a conceptual understanding to that, so that you could be able to do what? You could be able to do what? To explain to a person, how are you going to use this theorems to ensure that at the end of the day, you are able to respond to the questions. Ensure that this toolbox is ready whenever you are going to answer any questions. So if you have this toolbox with you, you will never get cycle geometry incorrect. So that simply means this toolbox will definitely assist you in answering cycle geometry, as far as I'm concerned. And then also, let us also remember that, yes, there are theorems that you will have to know how to prove. There are theorems that you will definitely need to know how to prove. So that I will leave it to your teacher to also assist you with such theorems. This is one of them. Line from the center, being it perpendicular to the what? Being it perpendicular to the chord. So if you are given OT and then RTS is perpendicular, so that angle T2 and T1 are 90, then you must prove that RT is equals to TS. I will leave this proof to your respective educators. Try by all means to ensure that, remember, geometry is creative rather than analytical. And learners often have trouble making the leap between algebra and geometry. They are required to use their spatial and logical skills instead of analytical skills. They were astonished to be to using in algebra. Now, with enough practice, you can do it. So that simply means with enough practice, you will definitely win at the end of the day. So with that being said, I would like to thank everyone for attending. Thank you very much.